What's up, everybody? I was planning on doing this follow-up part 2 video to graphing quadratic functions tomorrow, but I'm just like, it's late. I got nothing to do, really. I could have played some Super Smash Brothers, but I'm just like, anytime's a good time for quadratics, and anytime's a good time for algebra. So I'm like, shoot, let's knock out some math tonight. Shall we? Now, I know probably none of you guys are probably hopping on YouTube or jumping on Google Classrooms anytime soon to knock this out. But if you are, extra credit, all right? But anyway, I'm like, let's tackle the rest of the examples that we didn't tackle earlier today or in the previous part that we were talking about earlier when we talked about quadratic equations, quadratic functions. So I've kind of started right here, throwing it up onto the board, example 2. And for those of you watching this video, whenever you get a chance, I hope you follow along with me. So let's just kind of summarize what we talked about in the previous video. I introduced to you quadratics, and I mentioned that quadratics are is the math of curves, right? And most important with quadratics is you're looking for that x squared term. I also mentioned that standard form is that f of x equals ax squared plus bx plus c, where a, b, and c are simply just numbers, right? Any kind of real number. A cannot equal 0. And so we talked about actually graphing the thing, and I said it was kind of that U-shaped, and we used the term parabola, right? Parabola is the shape, and that's what we've got right here. And the first example that we covered involved us plugging values into a table of values and using just some good old-fashioned algebra and arithmetic to crank out an actual coordinate. And when all is said and done, you should have the pattern of a U either upside down or right side up, and you run your curve through it. It's just a good aim to connect the dots. So in this example, in this second part, we're just going to dive a little bit deeper into it, talk about some more specific terms that we did not talk about in the first part, and ultimately wrap up this chapter 4, lesson 1. So you'll be comfortable enough doing it on your own and covering the lesson that I've assigned to you in Google Classroom. All right, so I'm sure you're watching this not the same time I'm doing this, which it's way after 10 o'clock, but join with me and we'll get through it, all right? So what I've got here, I've got an equation. So I'm on example 2, and if you're following along with me, as I mentioned earlier, we are at the top of page 221. Top of page 221, chapter 4, lesson 1. And I've got an example here. So my function, my quadratic equation here is f of x equals x squared plus 4x minus 3. We can see it is in standard form. Ax squared plus bx plus c. In this case, when there's no actual number out in front of your x squared term, we assume that a, in this case, is 1, and we don't write down 1. So the three new terms that we're talking about here, and for some of you it might not be new, is we're talking about your y-intercept, your axis of symmetry, and your vertex. And right here on the graph that I've drawn, I'll label those and I'll identify them. Let me give you a really quick heads up too. This equation, this function, and this graph are not the same, okay? I just drew a generic graph of a parabola just to kind of label and show you what I was talking about. These don't make the same graph, so don't be fooled by that, okay? So first things first, when we talk about your y-intercept, right? Intercept is where something's crossing something else, if you've ever heard that term before. Intersect and intercept are not the same thing. Intersect is where two graphs cross each other, but an intercept, in this case, is where my graph is crossing an axis, right? So if I was to actually draw the intercept on here, I'll just put a dot here. This would be the y-intercept. that's where my graph crosses the y-axis. That's the y-intercept. Finding that's actually pretty darn easy, because what's happening here, if you're looking at x values, if you're on your horizontal x-axis and you're going left to right, when you're on the y-axis, your x value is 0. It has no value. It's a value of 0, right? So if I take my function up here, f of x equals x squared plus 4x minus 3, and I plug in 0 for x, I'll get where it crosses the y-axis. Let me show you what I mean. Instead of x, I'm going to swap it out with 0. So I've got f of 0 equals 0 squared plus 4 times 0 minus 3. That makes things real easy, because this is going to give us 0, and this is going to give us 0, so we just have minus 3. Okay, so in this case, my y-intercept, it will cross the y-axis at negative 3. I'll erase this in a second and actually draw the correct graph of it. I just wanted something to show you to label it real quick. Your axis of symmetry. Your axis of symmetry is an imaginary vertical line that goes up and down, and it cuts through the center of your parabola. It actually splits it right down the middle, and it's like the word says, symmetry means whatever's going on one side is being mirrored or the same on the other side, right? So it'll go right down the middle. So on this graph here, your axis of symmetry would look something like this. So something like this, and normally it's represented by a dashed line like you see here, because it's not an actual physical line that's on the graph. It's not really there. It's just kind of a boundary that we assume to be there. So you notice my axis of symmetry, half is on one side, half is on the other, right? And there's a specific formula for your axis of symmetry. So in this case, your axis of symmetry is x equals negative b over 2 times a. Negative b over 2 times a. We use the coefficients of your equation in standard form to figure this out. So in this case, and sometimes it'll help you to go ahead and identify a, b, and c before we go through all this. I didn't yet, but it's okay. A in this case, because we don't see a number out in front of x squared, we assume it's just 1, right? So a is going to be 1. B in this case is 4, because that's the coefficient out in front of your x term. C is negative 3. We don't really need C when we're trying to identify the axis of symmetry. Eventually, when we start using the quadratic formula to solve quadratic equations, we'll need C, but for this case, it's not important. Regardless, I still identified it. A is 1, B is 4, C is negative 3. Plug it into your formula. So if B is 4, then negative B is negative 4 over 2 times A. A is 2 in this case. Sorry, 1 in this case. So 2 times 1, negative 4 divided by 2 is simply negative 2. So the equation for my axis of symmetry is x equals negative 2. Once again, this graph does not represent this function. I'll do that in just a second. But this is your, right here, this is your axis of symmetry. Sometimes I abbreviate it. I just say A of, wow, it might be nice if I can write, A of S. Either way is fine, so I call it axis of symmetry, A of S, if you want to do a little shorthand. The last thing is your vertex. Your vertex is your highest or lowest point of your parabola. It's the point where it changes directions, right? So if it's a U-shaped, it's your lowest point. If it is shaped like an arch, if it's upside down, it's your highest point. In this case, it's going to be right here. Another way to look at it is it's where your axis of symmetry and your parabola meet each other, right? So that's your vertex. Finding your vertex is pretty darn easy. All you do is take whatever value you got for your axis of symmetry, plug it back into your function for s. So watch what I do here. My function, don't forget, is f of x equals x squared plus 4x minus 3. The two places here where I have x, I'm going to swap it out with negative 2. Okay? So you have f of negative 2. Remember, that's my result of my axis of symmetry. F of negative 2 equals negative 2 squared plus 4 times negative 2 minus 3. And we just simplify. To make everything a lot easier, because right now I can see my screen, I got a whole bunch of stuff going on up here. I'm going to go ahead and erase this graph that I drew over here. Just don't forget, where the graph crosses your y-axis is your y-intercept. The lowest or highest point, the point where it changes directions, is your vertex. That imaginary line that splits it right down the middle is your axis of symmetry. And we're going to draw those in just a second again. But just to make things a little bit easier to look at right now, because I'm limited on board space, I'm going to go ahead and erase this. Okay, and I'm going to go ahead and simplify this, what I got here. So, negative 2 squared. Now, I've seen a lot of people punch this into their calculators. You can't simply just do negative 2 squared into a calculator. Your calculator is going to think 2 squared, then make it negative, and you're going to get negative 4. That is not negative 2 squared. Negative 2 squared is negative 2 times negative 2, which will become positive 4. So don't fall into that trap, okay? Don't just punch it in your calculator. Notice how I have the parentheses around this? Plug it into your calculator with those parentheses, okay? So negative 2 squared is going to be 4, positive 4. 4 times negative 2 will be negative 8. Bring down the minus 3. 4 minus 8 is negative 4. Negative 4 take away another 3 is negative 7. So what does that mean? It means my vertex, when x is negative 2, y is negative 7. So my vertex, I'm going to go way down here on it. Negative 2, negative 7. That's the coordinate of my vertex. That's the, in this case, that's going to be the lowest point of my graph. So, let's graph it. Let's take all the information I have here and actually graph the thing. Now, at this point, I don't always have enough information to be able to graph it. Sometimes you're going to have to make that table of values that I showed you in example 1. Wake up, computer. Sorry about that. Computer falls asleep. Sometimes you actually have to make that additional table to come up with enough points to graph, but I think in this case, because it's symmetrical and it's parabola, we should have enough to actually graph the thing. Let's see what we can do. So I'm going to kind of make this small to fit up here, but let's start here. So I'm going to make my y-axis, or my f of x. I'm going to make my x-axis here. So I have f of x, and I have x. And I'm going to go ahead and graph what I've got. I know my y-intercept is at negative 3. It crosses the y-axis at negative 3. So I can go down 1, 2, 3, put my point there, okay? Next, I know the axis of symmetry is at x is negative 2. So I'm going to go back 2 on the x-axis, and I know there's a vertical line there. There's that imaginary dashed vertical line. going to go ahead and just draw that. Right? So there's my vertical line. There's my axis of symmetry. I also know that the lowest point is at -2, -7. So I'm going to go back 2, down 7. 1, 2, 3, 4, 5, 6, 7. Right about there. I really only have 2 points drawn, but keep in mind, a parabola is symmetrical, right? So if I'm down 3 and over 2 and down 3 from this axis of symmetry, if I go over 2, down 3 on the other side, there will be a point there. So 1, 2, 1, 2, 3. And like I said, this is kind of the lazy person's way of graphing it. Honestly, if I had more board space here and I was showing you in front of a full classroom, I would make a table of values over here, but I'm just kind of running out of space. So you got to bear with me. But anyway, it's going to be a parabola. It's going to be a curve. So right here, I'm going to go start down here at the vertex, go up one side, and then just mirror it on the other side. Something like that. Okay? It's not beautiful. It's not perfect, but you know, you get the gist of it and it gets the job done. Okay? I know, I just did a lot. I hope nobody has had a small stroke while I'm doing this. Okay? As always, you need help with a problem like this, give me a holler. I can help you out. But anyway, let me just summarize what I did here. Took my function, x squared plus 4x minus 3. I identified a, 1, b, which is 4, and c, which is -3. For my y-intercept, I plugged in 0 for x and simplified. I got -3 right there. For my axis of symmetry, I used my formula, which you need to at least highlight or write down somewhere. It is in your notes. It's in the handout that I've given you, but still, you need to point it out to yourself. X equals -b over 2a. Plugged in b, which was 4. -b becomes -4 over 2 times a, or 2 times 1 in this case. 2 times 1 is 2. -4 divided by 2 is -2. Take your axis of symmetry, plug it back into your formula for your vertex, vertex being the highest or lowest point. When I simplify it, I get -7, so -2, -7 is your vertex. Graphed all your points. We know they mirror each other. Draw a curve through it. Okay. All right. So that is axis of symmetry, y-intercept, and your vertex. Let's see what we got here. So I'm just scrolling back, continuing to scroll through your assignment. Let's see. So we've got an example 3 and example 4. You know what? Example 3 is pretty quick. Let's do another one like I just did. Okay? Let's do another one like I just did. And we're going to knock this out really quick. I just want to show you a second version of the same thing I showed you up here. All right? Don't flip out. If you're with me, if you're following along through the lesson with me, we are, let me see, we're at the bottom of page 221. So I want you to look at guided practice number 2 at the bottom of page 221. And this one has a negative number as the leading coefficient, so that's good. Just, we're stepping up the challenge a little bit. So let's take a look at this. All right. So if you're with me at the bottom of page 221, problem number 2, guided practice problem 2, we have f of x. Let's see, is that too high up there? No, we can read that. Negative 5x squared minus 10x plus 6. Okay, so we have negative 5x squared minus 10x plus 6. First things first, identify a, b, and c, like I mentioned in the previous problem. A in this case is going to be negative 5, because that is the coefficient out in front of x squared. B is going to be negative 10, and C is 6. Now once again, I mentioned C is not that important yet. It'll be more important as we get through more things involving quadratics. So, y-intercept to find your y-intercept, you plug in 0 for x in the function. So it's going to be f of 0 equals negative 5 times 0 squared minus 10 times 0 plus 6. This is going to give us 0. This is going to give us 0. So we're just left with 6, right? So your y-intercept will be at 6. Your axis of symmetry, remember I said you can just abbreviate it as A of S, make it easy on yourself. To figure out your axis of symmetry, you use our formula. X equals negative B divided by 2 times A. Well, if B is negative 10 in this case, then negative B will be positive 10. The signs will flip. So we get 10 over 2 times A, 2 times negative 5. That'll give us 10 divided by negative 10, which is negative 1. If we simplify that, last is our vertex. For our vertex, we take our axis of symmetry, negative 1. We plug it back into the function for x. So f of negative 1 will be negative 5 times negative 1 squared minus 10 times negative 1 plus 6. Let's simplify it and see what we get. Negative 1 squared is positive 1. Positive 1 times negative 5 is negative 5. Negative 10 times negative 1 is positive 10. Bring down your 6. Negative 5 plus 10 is 5, and 5 plus 6 is 11. So our vertex, I'll just write the coordinate down here, when x is negative 1, y is 11. So negative 1, 11 is going to be our vertex. Let's just do a quick graph of it. Once again, we could make a table of values. For simplicity's sake and to make it a little bit shorter, I'm not doing that table of values. On your actual assignment, there's a couple of problems you're going to want to do a table of values. I highly recommend get a hold of me, contact me so I can kind of walk you through those first few problems. Just be easier for you. But if you want to do it on your own, hey, I'll reward bravery. All right, so definitely jump on that. But let's go ahead and take a look at this. So we start with my y, or my f of x, and my x-axis, right? F of x, x. Let's go ahead and graph what we've got. So my y-intercept is at positive 6. So go up 1, 2, 3, 4, 5, 6. Put my point. Yeah, that's coming through okay. My axis of symmetry is at x equals negative 1. So I'm going to draw that dashed line right here. Okay. There I have my axis of symmetry. And I know my vertex is at negative 1 and 11. So we're going to go back 1, up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And back 1. So there I have my vertex. And once again, it's symmetrical, right? So I know whatever's on one side is going to be the same on the other. So I'm just going to put another point over here on this side. We have enough to draw a parabola, right? We could do them better, but we're going to just take it easy on ourselves. All right, and then my parabola is going to look something like that. It's going to be upside down and very, very thin. Okay, very, very steep looking parabola. But there we have it. We can see it's got everything we need to actually graph it. And if you want to check your work, as always, a graphing calculator. Also, there's some great websites you can go to check your work as well. Let me actually throw this up there, and I'll also toss it down in the description for you. A great website to go to if you want to check your work and you actually want to plug it into a graphing calculator. I'm going to erase this right here so I can put the website up here. Is www.desmos.com. And when you go to it, desmos.com, when you go to it, they'll give you an option to go to their graphing calculator. It's actually the same graphing calculator that's built into your Ohio State tests, your air tests. So it'll give you some familiarity. Works really easy. If you just plug this in as you see it here, it'll show you an example of it. You should get the exact same graph. Okay, so let's move on to example 3. Example 3 is pretty quick. We may even make this a 3-part video because it's kind of a long lesson. We'll see what happens. All right. Let's look at example 3. So if you're following with me, I'm on page 222. About midway down page 222, you'll see example 3 talking about maximum and minimum values. Maximum or minimum values. So middle of page 223, example 3. Now, the nice thing about this example, it's probably the quickest of the 3 examples we've done so far. Believe it or not, I've already shown you how to find your maximum or minimum values. It's actually where we found the vertex in the previous couple of problems. But let's just focus on that and that only. So your maximum and your minimum is basically, it's your vertex because that's either the highest or the lowest point, right? When we hear that term, maximum, so let's talk about this real quick. I'll put example 3 up here. But when we hear maximum, that's your highest point. Right? Your maximum is your highest. When we think minimum, that's your lowest point. Okay? So let me draw just sketch a couple of quick parabolas for you. If I had an upside down parabola like this one's going to have a maximum, right? This up here, your highest location where it changes directions, that's your maximum, okay? Your minimum would be a parabola like this. If it dropped down, changed directions, and come back up, that's your minimum. That's your lowest point. Okay? Well, if we're talking about a quadratic in standard form, f of x equals ax squared plus bx plus c, we need to look at a. Okay? If a is positive, so just a couple of quick rules is what I'm talking about here. If a is positive, if this first number, this leading coefficient is positive, you have a minimum. And I know that kind of seems counterintuitive, right? When we're thinking positive, we don't think minimum. We don't think small. We think positive with maximum, but it's opposite in this case. When your leading coefficient is positive here, you're going to have a minimum. You're going to have a parabola that looks like this. Okay? if A is negative, so if your leading coefficient here is a negative number, you have a maximum. So you're going to have a parabola that looks more like this up here, okay? Positive number, you have a minimum, you have a parabola that looks like this. Negative leading number, you have a maximum and a parabola that looks like this. So keep that in mind. I know it's kind of tricky. Rewind this video, play it back over and over again if you need to. Highlight it in your notes, write it down separate if you have to. Keep pounding it in your head over and over again until you kind of get that idea down. And it helps just as you practice it, right? So let's actually look at example 3. So I'm on page 222, middle of page 222. Let's look at example 3, and then I'll be out of your hair for this video, okay? We'll leave example 4 for a part 3 follow-up video. And I'm sorry that these are taking so long. This section, we just got a lot of material to cover, okay? If you need to watch this video in parts, I know it's funny, I'm 30-some minutes into it, and I'm telling you now to watch it in parts, but if you need to watch it in parts, then do so. So your brains don't go numb, okay? So let's look at the function. We have f of x equals negative 4x squared plus 12x plus 18. I can see just by the start of this, I'm going to go ahead and identify A, B, and C. A in this case is negative 4. B is 12. And C is 18. Now, if I'm just trying to identify maximum and minimum values, I actually don't need to find my y-intercept in this case. In the previous 2 problems, I had to find my y-intercept because I was trying to graph it, right? This, I'm not graphing, okay? I just want to know what is my maximum or my minimum value. What's the highest or the lowest point of this function? So, for this case, I'm just going to find my axis of symmetry, my A of S, and I'm also going to find my vertex. And keep in mind, that vertex, that's going to be my maximum or my minimum value, because that's where it's changing directions, okay? First things first, you know what, I'll switch the color up a little bit so I don't have all the same thing. X equals negative B over 2 times A. B in this case is 12. So negative B is going to be negative 12 over 2 times A. A is negative 4. So that's going to give me negative 12 over negative 8, or positive 1.5. Okay? Positive 1.5. Now, we take this 1.5 and I plug it back into the function, and that's going to give me my vertex. Okay, so it's going to be f of 1.5, so it's going to be negative 4 times 1.5 squared plus 12 times 1.5 plus 18. Now, normally I would say, look, plug this into a calculator, crank it out. I'm fortunate enough that I've got it sitting on the screen in front of me. Once you crank all this out, you're going to get 27. 27. So my coordinate, though, is 1.5 and 27, right? And since A is negative in this case, A is negative, it means the parabola is going up and then changing direction and coming back down. So really, my final answer is it will have a maximum. It's going to have a maximum at 1.5, comma, 27. So that's really my maximum, 1.5 comma 27. So you can see the amount of work that I had to do wasn't as extensive as the previous couple problems because all I'm doing is trying to find a maximum or a minimum, right? Let's do one follow-up exercise. Bottom of page 222, if you're following along with me. Bottom of page 222, guided practice number 3. I'm going to do this one real quick, then I'll leave you alone for the rest of the evening. We'll cover example 4 in the part 3 video, okay? You might think I'm going crazy cranking all this out, but in all fairness, friends, usually I cover this lesson over a course of an entire week with my class. So, 3 videos, that's pretty good for me. You all know me. I'm not a quiet person. I talk more than I probably should. I try not to. I try to keep my mouth shut. Keep things simple and brief. Y'all know me. It never happens. So, I apologize. Let's go ahead. F of x equals 4x squared minus 24x plus 11. First things first, identify your coefficients a, b, and c. A in this case is 4. B is negative 24. C is 11. Those of you paying close attention, we can see A is positive, so this one's going to have a minimum, right? It's going to dip down and curve back up. So let's go ahead, find my axis of symmetry, A of S. X equals negative B over 2 times A. Negative B, well, B is already negative 24, so negative B is going to be positive 24 over 2 times 4. It's going to be 24 over 8. Axis of symmetry is going to be 3. Okay? Take your axis of symmetry, plug it into your formula, back into your function. That'll give you your vertex. So your vertex in this case, 3 goes in, so f of 3 equals 4 times 3 squared minus 24 times 3 plus 11. Let's see if we can do this in our heads. 3 squared is 9. 9 times 4 is 36. Let's see, 24 times 3, that's going to give us 72. So what is 36 minus 72 is negative 36. Negative 36 plus 11 is negative 25. So, I think I did that math right. You can check me on it. If I did something wrong, put it in the comments below, but I'm pretty sure I did that right. All right, so that's going to be a, what was that? A minimum. Remember, A is positive, so when A is positive, when your leading coefficient is positive, you have a minimum at your vertex. It's going to be a minimum at 3, negative 25. Once again, did I do that right? And 36 minus 72, negative 36 plus negative 25. Math seems pretty solid to me. All right. So your lowest point is going to be at 3, negative 25. All right, guys. I gave you a lot of information. I threw out a lot of facts towards you. Don't let it all soak into your brain at once. If you need to take this video in parts, please do so. You should have enough information now to do maybe the first 10 problems of the assignment, the first 10 odd problems. As always, if you got any questions, please get a hold of me. Skype, Facebook Messenger, Google Hangouts. Shoot me an email. Give me a phone call to the phone number I've posted. There's lots of ways you can get a hold of me, okay? Don't let this stop you. Don't let, just because you're confused, stop you from trying it out. If you need the help, ask for the help. Keep your eyes open on my YouTube page. I'll be posting the third part to this video very soon. We'll start with real world example number 4, top of page 223. Until then, I hope you're all staying safe. Hope you all have a great night, and I'll check with you tomorrow. Take care, everybody.